everybody. Today we are looking at what I call the Arduino Burglar alarm. I would call it a starter project if you are just investigating how the ultrasonic sensor works, which is an essential part of this tiny system. I would still consider myself a beginner with Arduino. You can see my Arduino Starter Kit over there, which I totally recommend to use if you are new to Arduino. Most of the parts are coming straight from the kit, except for this ultrasonic sensor that I've mentioned. It's HCSR04. You can buy it on Amazon for like $6 or so. The other parts that I'm using are the Arduino Uno, two LEDs with current limiting resistors, and a piezo element. It's not essential to have even two LEDs, one would suffice. And of course the breadboard and wires. Pretty straightforward. So what this thing essentially does is it captures if someone's walking in front of the ultrasonic sensors, and that way detects if the alarm should be triggered. Without further ado, let's just see how it works. I'm gonna power Arduino with this power plug right here, and for the first 5 seconds basically the Arduino sets itself up so that it basically measures the distance between the ultrasonic sensor and whatever's in front of it, be it a wall under normal conditions, or in this case my GoPro itself. And after this calibration, it just is ready to sense if someone passes in front of it. Like if a burglar violates your house, it triggers an alarm. So these two LEDs flash, and the piezo element produces a sound as if the police car is coming your way. Let me show it again. First 5 seconds calibration, measuring the distance until the wall. Now it's ready, and bams. So that's definitely not the real alarm, simply because it can be disarmed just by unplugging the wall socket, which is not very safe. But you can try to power it with a 9-volt battery and see if it works. It might be a problem though, because this ultrasonic sensor is an active element, so it might consume quite a bit of power. But you can try. Essentially, even though this is not a real alarm, as long as you put it somewhere where the potential burglar or whoever you're trying to protect yourself from, if you put it there where he or she doesn't know where it is, it might work quite well. So just to give you a couple of use cases, when I go on the road trips, I'm always paranoid that someone from the hotel staff might get into my room late at night when I'm sleeping, and basically I don't trust them, so I put this thing just in front of the hotel room door, and that way I feel a little bit more protected. Also, if you have like a wife or a husband who is on a diet and late at night sneaks out to kitchen to grab something from the fridge, this thing can also come in very handy. Or also if you have a younger sister or brother who invades your private room once in a while, that's another great use case when you can use this thing. I'm actually thinking about upgrading this thing because right now it only produces the sound and flashes the lights, which is not very helpful if you are not anywhere nearby. So I was thinking about putting a Wi-Fi shield on top of this Arduino so that it would send you an email message or maybe a text message every time something bad happens. But there you go. Like I said, it's a pretty basic and easy starter project. You can totally try it yourself. I'm gonna switch over to my computer over there to show the sketch and explain how it works, and also to show you the wiring diagram. We're looking at the sketch and the wiring diagram for our ultrasensor Arduino burglar alarm. Basically, I'm gonna have both of these things up here, and I'm gonna go over the sketch line by line, and I'm gonna relate it to the wiring diagram or the schematics, and I'm just basically gonna review them in parallel. So let's go. First of all, we define some pins. Trick pin and echo pin are these active pins on the ultrasonic sensor. They are wired up to Arduino to pins 13 and 12 correspondingly. And then we have 3 actuator pins, red LED, blue LED, and piezo pin. So those are wired up to Arduino pins number 11, 10, and 8. And we'll use those to indicate different stuff and basically flash and produce sounds when the alarm gets triggered. Then we define our normal distance to 200 centimeters. That would mean that the sensor is able to sense, so that would be the maximum distance at which sensor can actually capture some movement. And then we set our boolean triggered to false initially. That means that the Arduino, that the alarm is not triggered when we just start our Arduino. As you might know, there are 2 methods, void setup and void loop, for in all Arduino sketches. Setup basically brings Arduino to the initial state when we just turn it on, and loop method gets repeated again and again for the whole Arduino lifecycle. So let's look at our setup method first. This serial begin is essentially for debugging purposes. You can omit this line easily. And then we set up our pin modes. So our trick pin is the output pin for Arduino and input pin for the sensor. That's why we set output pin mode for the trick pin to output. Our echo pin is our basically feedback from the sensor back to Arduino. That is why it's set to input, to be input. And then we set red LED, blue LED, and piezo pin pins to be output pins, essentially because those elements are actuators. Then we have our duration and distance variables, and you will see how we use them later. We set digital high on both red LED and blue LED pins to indicate that the calibration is in process. That's going to be the case for the first 5 seconds of the Arduino uptime. Never mind this line, actually it doesn't quite work, essentially because the piezo element needs variable voltage to produce some sound. So let's basically take a look at this while loop right here. This millis method call returns you the current time in milliseconds ever since the Arduino got powered. And as long as this time is less than 5,000 milliseconds, which is equal to 5 seconds, that's when this while loop will be executed again and again. First we do digital write to our trick pin. We set it to low, hold it there for 2 microseconds, and then set it to high and hold it there for 10 microseconds, and then set it to low again. What this essentially does is it sends out this square ultrasonic wave out from the sensor, which should be reflected and come back to the receiver of the sensor, and we read this receiver value by this pulse in function right here from the echo pin, and we write this value to the duration variable. That's essentially the duration or time elapsed ever since the square wave was sent out and received. Now, to calculate the distance until the object from the sensor, we're gonna divide this duration by 2 because the square wave has to travel forward and backwards, and then divide by 29.1, which is the pace of sound. Pace of sound being the 1 divided by the speed of sound, and we are talking about the ultrasonic speed right here. Now we check if distance is less than normal distance, then we set normal distance to distance. That basically means that if the distance until the wall or whatever that is in front of the sensor is less than 2 meters, then that's going to be our normalized distance. And then we turn off the LEDs and piezo pins to indicate that the calibration is done and we are now ready to sense. Now in our loop method, 2 sets of commands are available. One of them will be executed when the alarm is triggered and the other one when it's not. Let's consider our default state first, when the alarm is not triggered yet. So again, we have duration, distance. We send out the square wave through the trick pin in exactly the same way as we did before, and we retrieve the duration and calculate the distance in exactly the same manner. Now we check if distance is less than the normal distance minus 10, and 10 being 10 centimeters would be just our factor to make sure we don't trigger alarm because of some noises or minor moves. So when distance becomes less than that value, then we set trigger to true, and set a delay for 20 milliseconds to make sure our changes now propagate. And so the next time when the loop method gets entered, this set of commands gets executed because triggered is now true. So we set red LED to high and blue LED to low, and a specific signal to our piezo pin of this frequency, and then wait for half a millisecond, half a second, and then basically alternate the LEDs and set a different frequency to our piezo pin and wait another half a second and do it again and again and again. So that would alternate the LED flashing and also produce the sound from the piezo element that sounds like the police car approaching you. So here is the wiring diagram. Like I said, our ultrasonic sensor is an active element. That is why it needs VCC and ground power along with trig and echo pins hooked up properly. Piezo element is right here, is grounded on one side and connected to Arduino pin number 8 on the other side, and our LEDs have current limiting resistors, and of course our Arduino Uno itself, and of course we need to power the breadboard from Arduino. That's pretty much it. If you have any questions, please let me know. Otherwise, enjoy, and happy playing with Arduino.